All right, so we're continuing to work with the additional exercises. Let's take a look at number 8. We want to sketch the function. So we start going through our properties. So first of all, cube x times x times x is going to give me an x cubed. So my leading term would be 1/5 x cubed. So it means my ends are going to look like this. So we can immediately eliminate C and D. Those are gone. All right, let's go ahead and take a look at some other properties. Let's do our y-intercept. So if I evaluate my at 0, that would give me 1/5, 0 minus 3, 0 plus 3 times 0 minus 5. So that's a negative 9. Positive 45 times a fifth would be 9. So my y-intercept should be the point 0, 9. So it looks like it should be A. Let's just verify the x-intercepts are correct. So I should have one at 3, yep. One at negative 3, yep. And one at 5, and they cross. So A will be my answer. So we just kind of keep going through these properties until we can eliminate all the other graphs. So my answer choice would be A. Let's take a look at this next one. So again, I'm going to first look at the end behavior. This is going to give me an x cubed. That's going to give me an x squared. That gives me, when I multiply x to the fifth. So my leading term is going to be 0.2 x to the fifth, which I think of my x cubed function, no reflection, so that's my end behavior. So I'm going to immediately eliminate A and B. So my answer choices are now down to C and D. Let's see which one it is. Okay, so next, let's do the y-intercept again. So I'm going to evaluate f of 0. And let me grab a calculator and put that in. Make sure we have everything entered in correctly. Hit enter. That's 12.8. That's going to be kind of hard to tell here because 12.8 is not on the graph. But we can probably make a guess here. This one's going down here. But my y-intercept should be a positive 12.8. So that means this is going up here. This is probably going to be the correct answer. So I'm going to eliminate C, but let's verify. I should have a 0 at negative 4 and negative 1. So I do have a 0 here at negative 4 and negative 1. Odd, so it crosses. It just barely crosses there, doesn't it? And that's even, so it touched. So the answer choice should be D. That was kind of a weird one. Let's turn the page. Here we're given the graph of the polynomial function below, and we want to find the following. First of all, we want to find the minimum degree of the polynomial. So here, 1, 2 turning points. So my degree has to be one more than that. So I'm going to take 2 plus 1 equals 3. That would be my minimum degree. Leading coefficient is, my choices are positive, negative. Well, there's no reflection here, so it's positive. And degree's got to be odd. And then part C says the zeros with even multiplicity. Well, they cross at all three zeros, so there are none. Okay, zeros odd multiplicity. That's going to be -4, -1, and 1. My domain, polynomial function, that's automatically going to be all real numbers. Range, this extends on forever in that direction. That extends on forever that direction. So that will also be all real numbers. Okay, so then factors. Well, these are my zeros. So if -4 is 0, then x plus 4 is a factor. If -1 is 0, then x plus 1 is a factor. And if 1 is a 0, then x minus 1 is a factor. So that means the polynomial function, well, it should consist of x plus 4 times x plus 1 times x minus 1. Now, I might have a number in front of here. So what we want to do is say, as this is written, does this have like the correct y-intercept? So there's a point, -4. If I plug in x equals 0, that gives me 4 times 1 is 1, times 4 times 1 is 4, times -1 is -4. That does match my y-intercept. So this would be my polynomial function. All right, let's try number 11. So I've got 1, 2, 3 turning points. So my degree has to be at least 4. Ends are facing up, so my leading coefficient has to be positive. And the degree here is, well, ends are going the same direction, so it has to be even. Zeros with even multiplicity. Well, actually both of them do, right? -1 and 2. For odd multiplicity, there's none. Domain here is all real numbers. Anytime working with a polynomial function, it's going to be all real numbers. Range, however, well, this starts at 0, goes 0 to infinity. All right, so my zeros with even multiplicity were -1 and 2, so my factors have to be x plus 1 and x minus 2. Now, since they're even multiplicity, when I build this function, that means the power on these have to be even. So I'm going to try x plus 1 squared and x minus 2 squared. Now again, I might have a number in front of that. So let's see what that is. And I'm going to look at the y-intercept. So as it stands, I'm going to leave a little space here in case I need to put a number here. If I plug in 0, let's see what we get. So that gives me 1 times 4 equals 4. Again, leaving some space. But looking at my actual graph, I need a 20 for a y-intercept. Well, if I multiply 4 by 5, that would give me 20. So I'm going to multiply each of these by 5. That means I need to have a 5 in front of this to make the polynomial function work. All right, let's try a couple more of these. All right, so let's count the turning points. So here, remember I'm counting peaks and valleys. I've got 1, 2, 3, 4 turning points. Which means my minimum degree has to be one more than that. So that's 5. Which tells me that the degree is going to be odd. Now think of my x cubed function. My ends go like this on my x cubed function. But this has been flipped upside down. That tells me that the coefficient has to be negative. Okay, so let's look for the zeros with even multiplicity. Looks like I have 2 of them. One at -2 and one at 1. One with odd multiplicity where across is going to be at 0. Domain polynomial function, that's automatically all real numbers. Likewise, the range, this extends on forever this way, and this extends on forever that way, so my range is also going to be all real numbers. Okay, factors of the polynomial function. Well, I get 2 from here. That's x plus 2. I'm going to leave some space here. That will give me x minus 1. And then I also get 1 here. Now remember, 0 gives you a factor of x. So now when I build this out, I need to remember that these have even multiplicity, so I need to put some squares on them. Now, the problem I have here, I can't, to figure out what number I have to figure, I can't use 0, 0. I'm not going to be able to get a number from that because my y value is 0. I need to pick a different point on this graph. So looking at this graph, probably a good point is this point here. This is the point -1, 8. So if I value my function at -1, this should be equal to 8. If not, then we need to fix it. So what I'm going to do is I'm going to plug in -1. And I'm going to leave some space in case I need to insert a number here. Again, leave a little space. This is -1. This is 1 squared. This is a -2 squared. And let's see, so this is 4, that's 1, that's going to be a -4. I want my answer to be a positive 8. So that means I need to multiply this by -2. That should make sense because we said this coefficient was negative. So I need a -2 here. Let's try the last one. All right, so I've got, well, it looks like I only have one turning point. Okay, that's weird. All right, so the minimum degree has to be 2. Ends are both pointing down. That tells me my leading coefficient's got to be negative. And since they're going the same direction, power is going to be even. Zeros with even multiplicity be none. Zeros with odd multiplicity, well, we got one at -1 and 2. Okay, my domain here is going to be all real numbers. My range, well, it goes from -infinity. Looks like we're topping out at about, what, 8.5? So let's say 8.5. Again, we're just kind of guesstimating that. And then my factors, for my polynomial, I'm going to have a factor of x plus 1. And another one of x minus 2. Okay, so now I want to build this. Well, I can do x plus 1 times x minus 2. There's a problem though. If I FOIL this out, I would get x squared minus x minus 2. That graph should be a parabola. Well, that's no way a graph of a parabola. My parabola would probably look something like this, not like this. So there's something wrong. And it comes back here is that we just said these had odd multiplicity. It does not mean that the power is 1. The power could have been 3, could have been by 5. So I want to look back at each of these, and I look at this one. Look at how the graph kind of goes through that -1. It almost looks like my x cubed function. So maybe instead of a power of 1, this should have a power of 3. Okay, so now we just need to find the value. Here I can use the y-intercept because the y-intercept does not have a y value of 0, so that's good. So I'm going to look at f of 0. This is my proposed function. Again, I'm going to leave a little space. So that's 1 times -2 is a -2. That's a positive 2, so I want to switch the sign here. So I'm going to multiply it by a negative. So that means I need to have a negative in front. And so that would be my polynomial function.